Boris Choubert. Boris Choubert, or Schuberth, 1906 December 3, 1983, was a French geologist. An adept of Wegener's theory, he was the first to precisely reconstruct the layout of the continental masses of Africa, America, Europe, and Greenland prior to the fragmentation of Pangaea, 30 years before the article generally credited for this discovery. Biography. Of Russian origin, Boris Choubert, better known as Choubert, was born in St. Petersburg in 1906. He left Russia for Finland in 1917, then for France in 1927. He studied geology at La Sorbonne for 2 years, then at the Institut de Géologie Appliquée, now École Nationale Supérieure de Géologie in Nancy, where he received his diploma of engineer geologist. In 1933, he was employed by the government of Gabon, then a subdivision of French Equatorial Africa. In 1937, he defended his thesis on Études géologiques des terrains anciens du Gabon, geologic study of ancient Gabon terrains. In 1946, he was hired by the Office de Recherche Scientifique d'Outreau, more presently IRD, and left for French Guiana. In 1949, he founded a multidisciplinary research organization, which would become the Institut de l'Amérique tropicale Francaise Institute of the French Tropical America in 1954, then the Guyana office of Orstom in 1964. At the end of his stay, he was Inspector General de l'Orstom and the head of Bureau de Recherches Géologiques de la Guyane. In 1960, he came back to continental France. In 1961, he joined the CNRS as a directeur de recherche, then the École des Mines de Paris, where he stayed until his retirement in 1976. He then moved to Nice, where he was harbored by the Laboratoire de Géologie. He died in Nice on December 3, 1983. Scientific studies. Boris Choubert mainly dedicated himself to 3 geological fields, of which he significantly advanced the first 2, prospecting and mining geology, geological mapping and structural geology, igneous petrology. Mining geology. In Gabon in 1934, Boris Choubert discovered the characteristic minerals manganite and rhodochrosite of a huge manganese deposit, which holds a quarter of all world reserves. In 1939, he discovered the first diamonds in the alluvial deposits of the Ikoi River basin, near Lambarene Estuaire Province, Gabon. He would show later that these deposits are of secondary origin, and that these diamonds come in fact from kimberlites, the same as those from South Africa. In Guyane, he realized a detailed study of the gold mines of Saint-Élie and Adieu-Vat, and already drew attention to the problems generated by placer mining. Geological mapping. Boris Choubert achieved, alone or in collaboration, a great number of geological maps at various scales, from mine plans at 1/4000 to a global tectonic map at 1/10 million, with a particular attention at the magmatic and metamorphic rocks of ancient formations. In 1935, he published a very important paper where he reconstructs Paleozoic and Precambrian ranges and deduces the past existence and contours of the paleocontinent that predated the Atlantic Ocean opening. In French Guiana, he tackles the geological map of the territory 88,000 km2 at 1/500,000 scale, a map published in 1949 then, with more details in 1960. Boris Choubert and Continental Drift. Continental drift in 1935, evoked several times between 1596 and 1908. The continental drift concept was chiefly developed and advocated by the German meteorologist Alfred Wegener between 1912 and 1929, on the basis of different criteria, morphological, the nesting of continent shapes, like the Horn of Brazil and the Gulf of Guinea, stratigraphic. Wegener's studies obtained but limited success among the geological and geophysical community, for a number of reasons, in part because for every isolated argument one could appeal to coincidence or find some other explanation, but above all because the mechanisms that Wegener invoked as driving drift did not hold water. Boris Choubert was aware of studies by the South African geologist Alexander du Toit, who had evidenced the great similarity of ancient South American, West African, and South African formations, and was a supporter of Wegener's theory. Working on rocks from Gabon, Congo, and Brazil, Boris Choubert confirmed the findings of du Toit and in turn became a fervent supporter of continental drift. Reconstruction of the pre-Atlantic paleocontinent. Boris Choubert published in 1935 a reconstruction of the relative positions of America, Africa, and Europe before the Triassic. This reconstitution was much more precise than the previous proposals by Wegener and du Toit, essentially because Choubert, instead of using coastlines, based his reconstitution on the 1000 m isobath, a much better representation of the limits of continental blocks. That excellent fit was more convincing a proof of continental drift than previous attempts, which left a large gap between Africa and South America. For his reconstruction, Boris Choubert dared for the first time the idea that the Iberian Peninsula suffered, after the Triassic, a rotation with respect to the rest of Europe. He also swept the mid-Atlantic ridge problem by explaining that it formed posteriorly to Atlantic Ocean opening. The Caribbean Sea does not fit, as well as the rest, but, as it is known today, it was seriously affected by Cenozoic tectonics. Boris Choubert drew the theory farther than Wegener, who had only considered post-Triassic continental drift. By reconstructing the Paleozoic mountain ranges across the Atlantic Caledonian Range, Hercynian Range, and Appalachians, he made clear that they were formed by the compression of sediments that had been accumulated between three Precambrian cratons, Canadian Shield and Fennoscandian Shield at north, Gondwana at south. Withdrawing those ranges, he concluded that the three cratons had made a single continent at the end of the Precambrian, which was later fragmented during the Paleozoic. Hence, he realized that continental drift is a general process which has affected the Earth all along its geological history. The fit by Bullard, Everett, and Smith. 30 years later, Edward Bullard and co-authors published a paper in which a reconstruction similar to Choubert's was achieved with the help of a computer through the numerical minimization of distances between continental blocks. This paper rapidly acquired a great reputation among the scientific community, whereas Choubert's work had remained almost unnoticed, and it is even not cited in Bullard et al.'s paper. Notes and references.